So in this class, we'll talk about data preparation method for machine learning. Do you get that? Data preparation method for machine learning. So what I mean by data preparation method, they are the pre-processing techniques or method that is being used to prepare your data set for machine learning operations. Do you get that?
Okay.
So once you need to, in most machine learning, if you want to start a machine learning operation, any machine learning problem, you want to solve any machine learning problem, you might need to process your data set and make your data set suitable for the machine learning operation. Do you get that?
Okay.
So that is the definition of the data preparation method. So the first preparation method is the data cleaning. We might have talked about this case, this one, why dealing with data analysis. So data cleaning means that we want to remove values that are not good in the data set or missing values. Do you understand that? So it can either remove missing values from the data set, or we are going to remove fill the data set with maybe standard values. Do you understand that? So in while dealing with data analysis, I talk about how to remove missing values from your data set. Do you get that? So we can also remove missing values from data set, fill the data set with standard values. So we also have data transformation method. In data transformation method, we transform the data set into, we rescale the data set. You understand? We rescale the data set into maybe standard form or a form that is suitable for the machine learning operations. Do you get that? So for example, if you have maybe a data set in different scale, you might have collected data set of maybe you've collected data sets in salaries of people in different countries. You might need to scale it into a particular scale, maybe in USD. You can scale it in USD. Maybe you've collected salaries for different currencies. So you might need to make it in a particular scale. Do you get that? So data scaling, just data transformation is one of the data transformation method is data scaling. You understand? Just for you to transform your data set into a suitable way for your machine learning operations. So we also have the conversion to dummies and replacing data values with integers. For example, you collect data sets maybe for maybe genders of people, and the data set is either male or female. The data values are either male or females. So do you get that? So you can replace male with integer. Maybe you can replace male with 1 and female with zeros. Do you understand that? So that's replacing data values with integers. Maybe it's in categorical data set, maybe collected data set like race. Race, you have a particular attribute in your data set, which is race. And the race can either be Africa, Asia, maybe white. So then you can then replace these data values with numbers. You can see that anywhere there is white, you can replace it to 1. Anywhere you have black or Africa, you can replace it with 2. Anywhere you have Asia, you can replace it with 3. So do you understand that? So that is that about data transformations, data scaling, conversion to dummies. I'm still going to explain this conversion to dummies once you get to writing code. So if you want to convert data to dummies, you just representing it into 1 and 0s. Do you get that?
Okay.
So this is data scaling formulas. You have the minimax scaling, in which you standardize data set into minimax using minimax standardization. You understand? So minimax standardization has this particular formula. Your data points, a particular data point, you minus it from the minimum data points over the maximum data points minus the minimum data points. So let me show you. I'm going to show you the Python code. Let's get to Python code so that you can understand this process better. So the first thing we discuss is the data, starting from the data cleaning. So for example, if you have a data set, So let's use a pandas, create a small pandas data set. If you have the data set like this, so let's create a data set like this. Data frame, data. So you can create, let's create a data set frame like this. Name. So these are names of, we have name, Precious, Mike. So let's just have names and age. So we have age as another attribute in the data set. Age. Okay, let me use this one as strings. This should be strings. So dictionary like this. So we have 24, 22, and 23. And this is a particular data frame. So look at data frame. So let's say that in this data frame, we have a missing data, missing values. Are you with me?
Yes.
So if you have a missing values in this data set, like mp.nan, mp.nan is a missing value. So we look at data set, nan, it means that it is not available. This particular value is not available. So you can clean this particular data set. If these are data sets. So one of the data cleaning operation is removing data values with missing data. You understand? So this is the data values with missing data. You might decide to remove it. So to remove that, this particular data value is drop none. We use the drop none operation, data set of drop none. So it's going to remove that particular data values with missing data. Did you get that? So that is how to remove the particular data values with missing data, because once you are performing machine learning, you must not use missing values. Do you understand that?
Okay.
Do you understand that you must not use missing values for machine learning?
Dropping.
Do you understand that? So drop none means that it's going to remove all observations with missing values. I think we've used these functions. We've used these functions before during our data analysis class, right?
No.
We've not used it.
No, we didn't use it.
We have delete, del, I think, and some other ones.
Okay, so we also have this particular operation is removing missing data. Removing missing data. Removing data records. So it's a data record with missing values. So the data record is all this. These are the data record. This is what I mean by data record, or data observation with missing values. So another thing that we can do is filling the missing values. So filling missing values. I told that the pandas library is a collection of code that's used for data analysis, manipulations, and handling. Filling the data record with missing values. So instead of you removing the data values, so you can try to fill it with a standard values, filling the missing data record with missing values, with standard values. So this is another operation that can be used to clean your data sets. So this function is given by the pandas, like using the fill none. So fill none is mean that fill missing. Do you understand that? So we are filling missing. So if I should run this code, I think it takes a particular keyword, which is value. So this keyword value, and there's several methods of that value. We have the, okay, let's try the none. We have none. So none means that it's going to fill that particular with none. So instead of this, I can fill it with a missing value, that anywhere there's a missing value, put an age of 15. Do you understand that?
Okay.
So it's going to put an age of 15 in this particular missing value. Are you following? So it's going to put an age of 15. Is understandable, right? In this particular missing value.
Yeah.
Did you get that?
Yeah, we get it.
Okay, so another operation that can be done is, okay, you have a question, Abi? Do you have a question?
Yes, I have one.
Can we-
Hello?
Yeah.
Yeah, my question is, the first one is drop NA, right?
Yes. That you are
Okay.
moving the missing value.
Yes, that is if it is showing NA in all the data sets, but if you are dealing with so many or large data sets and we don't know what others are showing because we are not seeing everything. So does that drop NA we take care of every other thing?
Most times, missing values are represented as NAs, except you have some other representation. You can then standardize it. You understand? Missing values are represented as NAs. Do you understand that?
Okay.
Do you understand that?
Okay.
Missing values are
Okay.
represented as NAs, but in some data set, maybe your missing values are represented with maybe or represented with -999. This is another standard form of representing missing values. So you know that anywhere you see -999 is missing values. If you have this case, for you to remove your missing data, you have to first standardize it. That make your data set understand that this -999 is missing value. So you can use the replace function. So replace this -999 with mp.nan. So do you understand that? So this should replace this particular missing. But once you now replace, you can then use standardize. You can then remove the missing value with mp.nan. Do you understand that?
Okay.
So you can then remove the missing value with mp.nan. Do you get that?
Okay.
Okay, so that is that. So depending on your data set, because I've come across data sets in which missing values are represented by -999 or -99 or -9 or -5 or anything. Just in your data illustrations, you'll be given that your missing values are represented as -99. But in most cases, missing value, in fact, once you read the data sets in Excel sheet or CSV files, and there's a missing values, like in a spreadsheet, there's a missing values. Once you read it into Python, you have a missing value that is represented as none. It's going to is a normal standard way in which it's going to come out as none, like it's standard way. Even in some other data analytic tools like MATLAB, it's also none.
Okay.
Most anywhere in programming language, just say none. It's missing values, not available. Do you understand that? So the first method of filling data record with missing values, filling.
Yeah, hello, sir.
Yeah.
Yeah, I want to ask if you want to fill the data here by the mean.
Okay.
How can you go with the formula?
Okay, you can fill data with the mean. You might have calculated the mean. Do you understand that? You might have calculated it with the mean. Aside from that, there are other functions. There are also other methods with this. There's a particular keyword called method. method, we have the backfill method, in which is going to fill with the previous values. Let's see how it works very well. Data sets. So these are data sets. Backfilling. But the standard, another way of doing that is that if you see that dataset.age is going to give us the age attribute or the age attributes. Let's use this. So the age attribute, you can calculate the mean of this age attribute, that np.main, or even this, because it is a series, it's going to have dot main attributes or dot main attribute or property that you are able to calculate the mean. So with this now, you can calculate the mean, like m equal to the age values is the mean. Then you can then fit its value equal to m. So this means that if you replace your values with the mean. Did you get that?
Yeah. Now, like instead of this m, can we just put the whole formula? I send that value equal to dataset age dot mean.
Yes,
That,
yeah, it's possible. It's possible. It's going to work like this.
okay.
So it means that if you replace your values, your missing values with the mean of age. Do you understand that?
Okay. Yeah.
Do you get that?
Yeah.
So there is also a particular method of replacing. I'm trying to get that, in which is going to replace it with the previous value. So I've been trying to see which function is going to give us that. So if you have data set like our data set is this, which has a missing value for Mike. Mike age is missing. So you can then say data set dot fill none, that fill the missing value. We are filling the missing value with, so let's say value equal to, okay, let's say method equal to b fill. I'm trying to see the backfilling method if it's possible. Anyway, I'm going to look at the method for that. Before the end of this class, I'm going to let you know that. So let's proceed into another data preparation method that can be done. Okay, let's talk about the data transformation method. Data transformation method. So data transformation method, there are several data transformation methods. So we can say to transform your data set. Okay, before we move to data transformation method, in this mic value, we can insert the values there already. Data.fill none. Let's just fill it with the mean of the data set. Like we use this function, values equal to the mean of age, the average value of age. So we won't worry that there is a missing data in our data set. So in this section, we just have to perform data transformation method. So looking at this data.age, this is the age values. So the first data transformation method that will be done is the min max. So in min-max, is you want to scale the data set into a range of 0 to 1. So, and you should know that min-max is always used for, it's only used for numerical values, numbers, continuous values. Do you understand that? Our data scaling is only for continuous values. So as we have our age attributes, so we can convert it into the range of 0 to 1 using this min-max formula. Do you understand that? And the min-max formula, you just have to find the np.min. You can use np.min. np.min, the minimum of this age at data set. Do you understand that? So the minimum of this age data set divided by the maximum minus the minimum. Do you understand that? np.min, np.max. So this is going to rescale the data set into a range of 0 to 1. So let me show you the formula again. So you can see the formula now. Can you see the formula? The formula for minimax.
Yeah.
So we have the minimax. So each of these data points is going to be subtracted from the minimum value. Then the maximum data points is going to be subtracted from the minimum value. So you divide your numerator with your denominator. So we scale data set into a range of 0 to 1 using min-max scaling. Did you get that? Do you get that? So that is what is done here. So let's say that we have our age attributes like this. Age equal to data set.age. I want to make it simpler for you so it's understandable. Data set.age is our age. So we have data set.age like this. So then we can rescale this data set like as age minus np.min of age, the minimum of age. Then you subtract, you divide everything by np.max of the age, then you subtract it by np.min of age. So this is going to scale it into a range of 0 to 1. So our original data set looks like this. So you can see that 24 have 1.0 as the scale value, and 22 has 0 as the scale value, and 23 has 0.5 as the scale value. So this is scaling it into a range of 0 to 1 using the min-max standardization. So do you understand that?
No.
You don't understand that?
Yes.
Okay. Justin, do you understand?
Not really.
Okay, so let me try to create a better example for you to understand. You should understand that data transformation method is a procedure in which you transform your data set into a scale, into another form that makes it much usable for machine learning. Do you understand that? Just imagine that you have salaries, as I mentioned earlier. You have continuous values or age, something like this, age of different values. Let's say np.array of age of several values like this. So let's say 45, 22, 67, 5, 88, 12, 44, 15, 20, 10, and 5. Do you understand that? So we want to rescale this particular age into a scale of 0 to 1. So that is what we call data scaling. Do you understand that? We want to scale it into range of 0 to 1. Then one of the method of scaling it is the min-max method. Min-max, in which we determine the minimum and the maximum value. Is that okay? So like the minimum value, we have the min of what? Age, and the maximum value, max of age. Do you understand that? So then the formula is now you subtract each of the data points minus the minimum value. Then you now divide everything by maximum value minus the minimum value. So this is going to rescale it into a range of 0 to 1. Do you understand that? So this is going to rescale it into a range of 0 to 1. So look at the scale now. So you can say that this one that has 0 is the least. Why the highest value is 88, which is the one at the third index. You have 0, 1, 2, 3. You see that it's having a range, a scale value of 1.0. Do you understand that?
Okay.
Do you understand this min-max formula? You just each of the data points, subtract each of them with the minimum value and divide it by the maximum value and minus the minimum value. So it's going to scale your data set into a range of 0 to 1.
Okay.
Is it clear?
Yeah.
It's very clear, right? So that is that about the min-max standardization. It's just for you to rescale. There are a lot of standardization operations. You can standardize your values into maybe 1 to 5. Do you understand that? Like this particular range, I can standardize it into 1 to 5. So I just want to see the age into, like, you understand, look at this particular grading system in school, GP, in which someone will have 2.5 GPA and 3.5 GPA. That is a scale. Your result has the scale between the range of 0 to 5. Do you understand that? That is a perfect example of data scaling. Do you get it?
Okay.
So that is a perfect example of data scaling. If I want to scale into this one into a range of 0 to 5, I will know that the minimum value of this age is of 0 to 5. The minimum value is 5, 0, and the maximum value is 5. Do you understand that? Minus 0, something like this. Okay, this is not really falling into range of 0 to 5. No, I think it won't work like this. There's a reason why it won't work like this. We have to define another formula for this, for scaling it into a range of 0 to 5. Do you understand that? Do you understand that? So, but with this particular scale, we can just multiply this one by 5 because it's already between 0 to 1. If you multiply this one by 5, it's going to scale it between 0 to 5. So like 0 to 5 scale. So in which the 5th scale is the highest scale, which is 88. Do you understand that? Do you understand that?
Okay.
This is a very simple formula. I don't know why it's quite confusing for you. I think it seems when time is come to math like this, you guys are always feeling somehow.
Math is not easy.
But this is not just a simple math now. Just like you have 45 like this. 45 minus the minimum value. What's the minimum value of in this particular year? You have 5. 45 minus 5 over 88 minus 5. That is just the formula. Then you get this particular value, the first one here, which is 0.482.
Okay.
And another, if you want to scale this 22, it will be 22 is a data point. I told you that each of data points will be subtracted from the minimum of the whole data over the maximum value minus the minimum value. Do you get that?
Okay, I understood now. That's why to be doing it one by one.
Exactly, because we are using NumPy. So you don't need to do it one by one with for loop. So that's why I just take the OH at once. It's going to calculate because it is NumPy. NumPy is used for multidimensional computations. It's going to compute it, unlike list that you need to iterate and compute it one by one.
Okay, but this NumPy function, can we call it iteration also?
It's going to compute all your array items at once. Okay. So it's not iterating, although in between your code is going to iterate, but you don't need to worry about if it's iterating or not. It's going to compute everything one by one. So another standardization formula is the Z-score standardization. Z-score. Do you understand that? Z-score. So using this particular formula, this value divided by the mean minus your data points minus the mean of the data over the standard deviation. Do you understand that? So we need to calculate the mean of age, np.mean of age divided by the standard deviation. This particular min-max standardization is commonly used because it gives a better accuracy. It assists machine learning functions better than the min-max standardization.
Okay.
So the formula is simple. Each of the data points is subtracted from the minimum data points, from the mean data point or the average data point divided by the standard deviation. So if you look at the formula, we have this as our formula. X, each of the data points, which is subtracted from the mean data point, the average data point. Then we are going to divide it by the standard deviation.
Data point. Yeah.
Do you get that?
Okay.
Yeah.
I'm following.
So that is that about the standardization method. Although there are a lot of formula for standardization, I think there is logarithm transformation. You can also transform your data into logarithm. Do you get that? You can transform your data into logarithm. Do you get that?
Yeah.
So you can logarithm scaling. You can transform your data into logarithm scaling. That has a particular formula also. So, and it is useful in some cases because some machine learning algorithms are not really comfortable with you having higher values. Like maybe you are taking, you are modeling house pricing data. Then you're having higher values like 5,000, 2,000, higher values like millions. Do you understand that if you scale your data into a range of 0 to 1, your machine learning model will perform better? Do you understand that?
Okay.
Do you understand that? So most time machine learning model perform better once it is being scaled to within that range. So let's then proceed. And regarding this particular formula, this particular phenomenon that I said I'm going to tell you about, how to fill with the previous values. So here we standardize it into, okay, we remove the phenomenon here. So one of the method is this. I think before we do that, we have to first replace it with none. It has to be standardized to none, like data set equal to data set dot replace. So I can replace np.none with none. So it has to be standardized to none if possible. Then I think this should now work. So this now replacing previous. So for you to use all this replacing previous, replacing with main, replacing with using the several method of filling none. It has to be standardized to none instead of np.none. Let's have a timeout now. We'll come back so we can talk about this filling none again better.
Okay.
So in the previous class, in the previous session, I was trying to explain this fill none better. So the reason why our method of fill none is not working is that we are not using none. Instead of none, we should be using none to standardize missing values. Do you understand that? So standardized missing value means that to represent missing values. Do you get that? So I think using this none, we also change it to none here. It has already changed to none. Whether you use none or none, it should make the same thing. Do you understand that? So we'll now try the fill none. So using the fill none method, so we'll start from the bfill method. So if I should run this code, so it should fill it with the previous values. Okay, I think it's not even working still. So we should just standardize it to missing. We should replace the none with none. So we are going to replace the none with none. np.none none. So we are going to replace it as none. So it's going to be represented as none instead of none. So do you understand that? It's going to be represented as none. Wait, let me try to run it. I'm trying to get a particular thing, data set. It seems our data, this has already been replaced. No, it's not working yet. So let's now replace it with none here. This thing is really disturbing me. So I wonder I am getting 22. Yeah, I should get none instead. This is a none value. Wait, I'm going to refresh this kernel. Are you with me? Hello.
Yeah, we hear.
Okay. So I'm trying to refresh the kernel.
Yes, we're here. All right.
I already rephrased the kernel. It's still the same thing. Let's try to go to another thing. This is really I'm getting confused in this field NaN functions. I'm going to make I might make another video for this field NaN class. So using this field NaN function. Do you understand that? So I'm going to see why this is getting to 22 just because we just replace the values, which shouldn't be. Because if you look at this line, we read our data set as this, we fill it the data set as minus 99. Are you getting that? So in this line, so I'm trying to replace minus 99 with none. So, okay, let me try to replace it with none. Let's see if it's going to work with none. So okay, it works with none. So okay, let's now use the fill NaN method. So I'm getting several strange values. D.fill NaN instead. It's not working. So I'm trying to make it none instead. None. So making it none is taking the previous values. Do you understand that? So I'm going to see the reason why it's taking the previous values. So I'm expecting it to take none, to take it as none in this H value instead of none. Do you understand that? So let's just move to another data preprocessing method. Do you understand? Let's move to another data.
Okay. Okay. Because I run it on my own too. Is getting the previous figure instead of none.
Instead of none. That's okay. So
Yeah.
let's talk about the data dimensional reduction. So in dimensional reduction, so we attempt to refit our data set into new plane in order to reduce the data set dimension. So what I mean by data set dimension is that we have a data set in which you have several dimensions, maybe several attributes, age as an attribute, gender as an attribute, as much as possible. Then you have several dimensions in your data set. So you might need to reduce the dimension by fitting it into new plane. So that operation is called the dimensional reduction. Do you understand that? Then the method commonly used for dimensional reduction is the principal component analysis. You might not need to understand the math behind it because there's an inbuilt code that can be used to refit your data set into a new plane. Do you get that? That can be used to refit your data set into a new plane. But before we go in depth into dimensional reduction, I want us to also talk about before that, in this data transformation method that we just did, in data transformation, I want us to talk about replacing with integers, replacing data values. Maybe the next class we'll talk about dimensional reduction, the code for dimensional reductions, replacing data values with integers. So if you look at these data values, if you look at these particular examples, if I try to extend this as example, then I included our gender instead as, as another data variable or attributes in this set, in this data set. If I add gender, then I have gender which could be either male or female for each of the names. Yeah, so you can just create a random gender like female, female, male, and female. So do you understand that? So if you look at these data values, most times you know that machine learning codes they are mathematics. Most of them are mathematical formulations in between your functions that might need numbers as an input. So you might not want to give your gender as an input. So you might try to what replace the values with integers. Do you understand that? So these are the genders, female, female, male. So I can try to replace it with integers. Do you understand that? So you can replace this with integers using the replace function. We say replace, I can use the replace function that I'm replacing two values, female and male, with one and zeros. So something like this. So now I've replaced this female and male in this data set with one and zeros. Do you understand that? Do you understand that?
Yeah.
Okay, yeah, we replace it with one and zero. But in some cases where we have several attributes in your data set, you might not even know the numbers of attributes in your data set. Do you understand that? I can use pd.unique and try to replace it. Do you understand that? For example, I can say that pd.unique value of gender. I can try to get the unique values of gender. So I know that I'm going to have male and female. Dataset unique. Dataset.unique. Dataset.unique. Something like this. Dataset.gender, I mean. So we have female and male as our unique values. So from these unique values, then I can then replace this with the numbers here. I might need to look at how I can create a random numbers. I can assign numbers using Python code with these unique values. Do you understand that? I can do that like, say, like something like this for I in range unique values, something like this. For I in range len unique values, something like this. So we have 0 and 1. So with this, do you understand how I created this? I'm trying to assign these unique values. I'm just assuming that, for example, we have several unique values that you might not even know the total numbers of items in the data set. I want to replace it with an integers and increasing integers. You can use this approach, compute the unique values of the attributes. In my case, I will only have two unique values, which is male and female. And with these unique values, I want to estimate, assign values to them, which are starting from 0, 1. If I have maybe male, female, and transgender, I can then have 0, 1, 2. Do you understand that? So with this code here, for I in range len of unique values, I know that I'm going to get I for each of the range, and the range is going to range from 0 to 1, 0 and 1. So these are the values I want to replace now. Values that I need to replace. So then I can then replace this that mp p the data set dot replace unique values, comma values. Do you understand that? Unique values, comma values. So with this, it's going to perform the same function. Do you get the logic behind this code? It's quite complex, right?
Yeah.
It's complex. It's quite complex. Or do you understand? You understand what I'm trying to achieve here?
Yeah, we got it.
How about Olayemi? Do you understand it? It's quite complex. Hello? Hello? Do you understand?
Yeah, hello.
I'm talking to Olayemi and Ojina. Do you understand? Wait,
Yes, I'm following. Yes.
you are following. I hope you understand that. So what I'm trying to say is that let's say that we have several values. So instead of just listing the replace gender, so for example, I have another stuff here. I have male, female, and transgender. So you might not want to list all your values. There might be several values. The traditional way of doing that is just to say that replace, just start replacing the values, each of them, male, something like this, comma, female, something like this, comma, female, then, comma, 0, 1, something like this. So this is going to, okay, if you still have transgender that is not replaced, transgender. So I would like to replace transgender by 2. So you have something like this. So this traditional way of doing that. But in some case, you might not know the whole unique values. You might not want to be listing them. Just think of it. We have a list of countries. Like if you remember our COVID-19 data that we did. You want to replace all the countries with numbers. You can start listing each of the countries. Do you understand that? We and start listing, creating numbers that will be assigned to them. Do you get that? So to do that is that you have to use this. You can try to calculate the unique values like we did here. First calculate the unique values. Then once you calculate the unique values, create a code that is going to assign numbers to them. Like here, this code is going to assign numbers to each of these unique values. Female, male, and transgender. Do you get that? This code is going to assign values to the unique values. Then we can then replace. You can then replace. Do you understand that?
Okay.
Do you get that?
Yeah.
Okay. So let's just stop at this part. Let's stop at this point. I'm going to. Were you able to review the last class lesson? Because I've given you several assignments and you've not been doing it. The last class lesson, I told you to look into the lesson that we did, then try to extract the key topics of the class, and you can then make your further research on that. That was the assignment. So I want you to do that. And this new assignment I'm going to give you is just for you to, I'm going to send you documentation on FieldNAN. This FieldNAN that we were unable to, that is confusing us. Dataset.FieldNAN that is confusing us. So I'm going to send the documentation on that. So all the code within the documentation, you have to practice that. Did you get that?
Okay.
So you just have to practice the code within the documentation. So what it looks like. So I'm going to send the documentation, pandas documentations on the topic of Finland. So it contains several codes on craft Finland. You can practice it. So send me, then you are going to send submit. You are going to submit a Python code that has exactly the same examples, but with different values as that of the documentation. Just like the documentation, if you have this particular example, something like this, quanta, precious, and might, you can use another name. Do you understand that? Use another name, change the name, change the values here, then use your Finland operations that was used in the documentation. Is that clear?
Okay.
Okay, so that will be your assignment. So do you have any questions regarding this class before we end the class?
I don't have question.
Okay.
No, I don't have a question.
Ajina, you have a question?
No question. Just upload the video. I will go through it again.
Okay. So I'm going to upload the two videos, the one for yesterday and for today. So is that okay?
Okay.
So we'll meet next week.